Now let us discuss some exercise questions from chapter 3, lever topic. Take page number 52, numericals example 1. If the fulcrum of a crowbar of total length 150 cm is at a distance of 25 cm from the load, what is the mechanical advantage of the crowbar? Look at the diagram given. One crowbar is shown and the distances are marked from load to fulcrum 25 cm, fulcrum to effort 125 cm. This distances we call as effort arm and load arm. Distance from effort to fulcrum, that is 125 cm, is the effort arm. 125 cm. Load arm is 25 cm. And you are asked to find out mechanical advantage. The formula for mechanical advantage of a lever is effort arm by load arm. Divide it, you will get the answer. Remember, this formula MA is equal to effort arm by load arm is only for levers. This formula is only for levers. And another formula you have learned in theory, MA is equal to load upon effort. This is general formula applicable for all type of machines. Now example 2, the following figure shows a stationary wheelbarrow of weight 15 kg force containing sand of 60 kg force. The center of gravity of the wheelbarrow is at A and its wheel and legs are in contact with the ground. You can see in the diagram the wheel, center of the wheel is the fulcrum and the leg touches the ground. The tip of the handle of the wheelbarrow is at the point B and the center of its wheel is at point marked as F. As shown in the figure, the horizontal distance AF equal to 50 cm and horizontal distance AB equal to 100 cm. First question, in which direction does the force acting at A act? At A, it is given A is the center of gravity. So the total weight acts at center of gravity A. So the force acting here is called as load. Load acts downward. Then how much is the load? Weight of the wheelbarrow, that is 15 kg force plus sand weight is 60. So 15 plus 60. The load is 15 plus 60, that is 75 kg force is the load acting at A in downward direction. Second question, in which direction should we exert a minimum force at B to keep the leg just off the ground? Name this force. At B you have to exert certain effort. The force we call as effort. How much effort is needed just to bring this leg off the ground? Means leg of the wheelbarrow should just get raised above. For that, how much effort is to be applied at B? Here, from the figure, you can see what is the load arm and effort arm. So remember the points. Fulcrum is shown already. A is the point where load acts. B is the point where effort acts. So from the figure, find out the effort arm, load arm, then find out MA by using the formula effort arm by load arm. Both are available, these two. So find out MA, then use the formula MA is equal to L by E. So E you can find out. Now page number 53, example 3. A man uses 2.5 meter long crowbar to raise a 100 kg mass or weight of 1000 Newton as shown in the figure. Find the effort needed to lift the load and the mechanical advantage of the crowbar. Here that triangle shape in figure, you see a small triangle, that is the fulcrum, where the man holds, that is the effort, and the load is already shown. So MA you can find out by the formula effort arm by load arm. Then first part you are asked to find out the effort. Here load is given as 1000 Newton. In question it is given. Effort arm and load arm are available. Effort arm is 2 meter and load arm is 0.5 meter. So use the formula of principle of lever. Effort into effort arm is equal to load into load arm. From that you can calculate the effort. Then use the formula for MA. Either use the formula effort arm by load arm, or you may use the formula load upon effort. Like that you can find out MA and effort. Next example 4. Handle of a nut cracker is 18 cm long and a nut is placed 2 cm from the hinge. If the force of 36 kg is placed on the nut, it will crack. Calculate the force which has to be applied at the end of the handle to crack the nut. Means you are asked to find out the effort. Load is given 36 kg force. And in the figure already fulcrum is shown and the nut kept is the load and effort is already shown at the end of the handle. So you can find out how much is the effort arm, load arm, and load is already given. So you can find out the effort by using the formula load into load arm is equal to effort into effort arm. Now page number 54, example 5. A pair of scissors is used to cut a piece of cloth placed 2 cm from the rivet. Look at the figure. This cloth is kept at a distance of 2 cm from the rivet. This is the rivet. That means distance from fulcrum to load, that is 2 cm. Load arm. A force of 8 kg force is applied by the fingers. That means effort is 8 kg force. Here on the fingers the effort is applied by fingers 7.5 cm from the rivet. From rivet the distance to effort, that is effort arm, is 7.5 cm. Then you are asked to find out what is the resistance offered by the cloth. Means load you have to find out. You know the effort arm, load arm and effort. Load you have to find out. Use the formula load into load arm is equal to effort into effort arm. Now take page number 55. Solve these numerical. First one. The mechanical advantage of a machine is 5. That means MA is equal to 5. And its efficiency is 80%. 80% means in decimal form 0.8. It is used to lift a load of 200 kg force. Load is 200 kg force to a height of 20 meter. That means displacement of load is 20 meter. Calculate the effort. Effort, how to calculate? First you have to use the formula for MA. MA is equal to load upon effort. From this formula you can calculate effort because load is given, MA is given, so effort you can find out. Let us calculate. MA is equal to 5, load 200 kg force, effort unknown. Therefore, effort is equal to 200 upon 5, that is 40 kg force. This is the effort. Now same question, you are asked to calculate work done on the machine. For that, use the formula efficiency is equal to work done by the machine upon work done on the machine. So work done on the machine is equal to efficiency into work done by the machine upon efficiency. Just rearrange the first formula. Once again, efficiency is equal to work done by the machine upon work done on the machine. So work done on the machine is equal to work done by the machine upon efficiency. Now how will you find out work done by the machine? That is load into displacement of load upon efficiency. So load is 200 kilogram force. So you have to convert it into Newton, multiply with G. It is given 9.8. So load is given in the question kilogram force unit. To convert it into Newton, multiply with G. Displacement of load is given as 20 upon efficiency is 0.8. When you do this calculation, you will get work done on the machine. Now question number 2, already that type of questions we have solved, so you can try by yourself. Question number 3, a cook used a fire tongue pair of length 32 centimeter to lift a piece of burning coal of mass 500 gram. Fire tongs, what you call in Hindi as chimta, that is fire tongue. For a fire tongue, here is the fulcrum, here is the point where we are applying the effort, here is the load we keep. So load is given as 500 gram. The load kept here is 500 gram force. This is the load kept. Okay, it is 500 gram mass, means weight or load is 500 gram force. If he applied an effort at a distance of 8 centimeter from fulcrum, this distance is given as 8 centimeter, that is effort arm, 8 centimeter from the fulcrum. What is the effort? Effort you have to find out. The total length of the fire tongue is given 32. This is total length. That is actually load arm. Look at the figure, it is load arm. So you have these many things: load, effort arm, load arm, effort you have to find out. Then use the formula load into load arm is equal to effort into effort arm. Then you can find out what is the effort. Effort you can calculate. Same question, assume friction is absent. Also obtain values of MA and VR of this machine. MA you can calculate easily, divide L with E. L by E will give MA. Then how will you find out VR? VR is equal to MA if the machine is ideal. Look at the question, it is given friction to be absent. Assume friction is absent. Friction is absent means that machine is an ideal machine. Ideal machine means machines having 100% efficiency. In such machines, MA and VR are equal. So what is MA? Same will be VR. Next question 4. Find the effort required to lift a stone of mass 120 kg with the help of a lever of 1.5 meter long if the load arm is 0.3 meter. effort you have to find out. Now see the question. Find the effort required to lift a stone of mass 120 kg. So load is 120 kg force. With the help of a lever of 1.5 meter long, this total length is 1.5 meter. If the load arm is 0.3 meter, this is the load arm, distance from load to fulcrum, that is 0.3 meter load arm. Then remaining length is effort arm, that is 1.2 meter is the effort arm. Then you are asked to find out the effort. So you know the load arm and effort arm. Effort you have to find out, use the formula load into load arm is equal to effort into effort arm. And you will get the answer as 30 kilogram force. In textbook answer is written 30 Newton, but your answer will come 30 kilogram force. Next question number 5, that also you can try by yourself. You are asked to find out MA, VR and efficiency. Use the formula MA is equal to load upon effort. VR, you have to find out VR is displacement of effort upon displacement of load. Both are given. Efficiency is MA upon VR. If you want efficiency in percentage, MA upon VR into 100. So these are the numericals. Now let us discuss some questions based on Icsc examination from page number 55. Second question. What can we say about the relative magnitude of MA and V velocity ratio VR for an ideal machine? For an ideal machine, MA is equal to VR. And practical machine, MA will be less than VR. In theory portion I have explained it. All might have watched that video. Now question number 3. Scissors and shears are levers of first order. However, the cutting edge of scissors used for cutting cloth is much longer than cutting edge of shears used for cutting metals. Explain the difference. Look at the figure. Scissors, that is familiar to you. For scissors, see where is the fulcrum, effort and load. And for scissors, this cutting portion is longer. Cutting blade portion is longer. But shears are also like scissors. They are metal cutters. The difference here is scissors are used for cutting paper or cloth, but shears are used for cutting metals. But its structure is different. See, the handle of the shears is longer, cutting blade portion is shorter, just opposite of scissors. And both are first order levers. Look at the diagram. In both case, fulcrum lies between effort and load. So both are first order levers. In theory, I have explained first order levers can have MA equal to 1, MA greater than 1, MA less than 1. All three possibilities are there. That means first order levers can be used as force multipliers as well as speed multipliers. Okay, look at the first case scissors. Here, how is its MA? Its MA is effort arm by load arm. Look at effort arm is shorter, load arm is greater. So MA will be, effort arm is shorter, load arm is greater means MA will be less than 1. MA less than 1 means it is a speed multiplying machine. Consider the case of shears. In case of shears, you can see that effort arm is longer, load arm is shorter. So when you calculate MA is effort arm by load arm. MA will come greater than 1. MA greater than 1 means they are force multiplying machines. So see the difference. Scissors are speed multiplying machines. Shears are force multiplying machines. Means in case of scissors, when you move your finger through a short distance, the cloth gets cut along a long distance. That is the meaning of speed multiplying machine. You may be moving your fingers through a short distance, but the cloth gets cut over a long distance. In case of metal cutters, you have to move your fingers through a large distance, but the metal gets cut through a short distance only. That means it is not a speed multiplying machine, it is force multiplying machine. Here we need a force multiplication because for cutting the metals, large force is needed, large effort is needed. That much effort we cannot apply directly. So we need a force multiplying machine in case of shears. That is why its effort arm is kept longer than load arm so that it can have MA greater than 1. Now question number 4. If a machine is to be used as a force multiplier and machine available is a lever, then what class of lever should be preferably used? Support your answer by a diagram. It is second order lever. Second order levers are force multipliers. Now ninth question. Can a simple machine act as a force multiplier and speed multiplier at same time? It is not possible. At a time it will either work as force multiplier or speed multiplier.